Hi, today we're going to talk about bonding, and there are three major types of bonds between elements. Now, before we start about that, we got to talk about what's the difference between an element and a compound. Well, an element is anything on the periodic table. In other words, hydrogen, lithium, beryllium, cobalt, phosphorus, argon. These are all elements. A compound is when you have two or more different elements that are chemically combined. And the reason when they're chemically combined, it is because of the behavior of the electrons. I'm going to give you a couple of examples. First of all, we have three major types of bonds. We have an ionic bond, we have a covalent bond, and we have a metallic bond. An ionic bond. First thing we want to look at is we want to look at the electronegativity values. Electronegativity just means how strongly or how badly an atom holds on to its electrons. When we look at electronegativity, sodium is 0.9, chlorine is 3.2. When we look at this difference, the difference here is 2.1. If the electronegativity values are above 2.0, this is a good rule of thumb. If they're above 2.0, chances are it's ionic. 3.2 is a very high electronegativity value. The maximum is 4, so 3.2 is up there. Chlorine is pulling all the electrons towards it. When we look at this compound, the individual atoms, sodium has one valence electron, and chlorine's going to have 7. 1, 2, 3, 4, 5, 6, 7. So chlorine is so strongly pulling, it's actually pulling this electron off of the sodium, and it's saying, you don't want that electron, I want that electron, give it to me. That electron goes right here. Now the only thing that's different here is, once we do that, the sodium atom is now a sodium ion with the positive 1 charge. The chlorine atom is now a chloride ion with a negative charge. When you have a positive and a negative, think about a magnet. They stick together. These bonds are incredibly strong. The strongest bonds that exist. Ionic bonds are very strong. But the second they go into water, they pretty much split apart. And we'll talk about that way in the future. However, ionic bonds are very strong. Because the bonds are very strong, they have a very high melting point. They also have a very high boiling point. And they do conduct electricity, however, only in the liquid phase. Now, a covalent compound, for example, hydrogen and chlorine. A covalent compound, you're going to look at the electronegativity values. Hydrogen is pretty electronegative, even though it's a nonmetal. Chlorine is very electronegative. But when we look at this difference, it's only 1.0. So it is less than 2, which is our good threshold to pay attention to. So what happens here is chlorine is not that much stronger than hydrogen, so it can't take its electrons. So what happens here is the hydrogen holds on to its 1 electron. And that chlorine holds on to its 7 electrons. But when you look at them together, hydrogen has a full valence. Remember, hydrogen only has 1 orbital. The first orbital can hold a maximum of 2 electrons. So this hydrogen is satisfied. When I look at the chlorine, it is also satisfied because it has 8 electrons. Now, one of those electrons is hydrogen's, and one of hydrogen's electrons is chlorine, but these electrons are being shared. So when they share the electrons, they're both happy. Chlorine also has an octet. Now this one is not, we don't write a charge on this because they're not ions. These are actually bonded. Another way of drawing it, and we'll worry about this later, is showing you like this. When you see a line like this refers to one bond, which is 2 electrons. So a double bond, something that looked like this, would actually be 4 electrons. And finally, metallic bonds are bonds in a pure sample of a metal. The only thing you need to pay attention to metallic bonds is this. Now when we have, for example, a sample of pure silver, we have Ag with 1 valence electron, another Ag with 1 valence electron, make sure it only has 1, and Ag with 1 valence electron. In a sample of a metal, since the metals are so big, they don't really hold on to their valence electron that strongly. But that also means that these valence electrons can jump from one atom to the next. And when this one jumps over there, then this one has to jump over there, and so on and so forth. This happens only in a pure sample of a metal. And because of this behavior of the electrons, again, because they're not held very strongly, metals conduct electricity. They also have a very high melting point and a very high boiling point. Now here's an easier way of doing this. When you have a covalent compound, like water, you're going to have a nonmetal binding with the nonmetal. This number right here just refers to quantities. We're going to deal with this in an upcoming video. However, all you're doing is you're looking, and if it's 2 or more nonmetals, 2 or more nonmetals, it is covalent. If you look here, we have calcium, which is a metal, and we have chlorine, which is a nonmetal. This is ionic. Again, covalent, 2 nonmetals, ionic, metal, and nonmetal. Now let's look at this. We have NaOH, which we have this is a metal, and these two are both nonmetals. Now the only thing that's different about this is if you see more than 2 elements, this is 1 element, this is 1 element, this is 2, this is 2 elements, I'm not talking about the quantities. Here I see sodium, oxygen, and hydrogen. If you see more than 2, so in other words 3 or more, you're going to have to look at table E. If you have one of these substances in table E, these are called polyatomic ions. And polyatomic ions, all that means is that you have covalently bonded atoms that are behaving like an ion. In other words, I have OH, which is hydroxide. OH has a negative charge. It is attracted to sodium, which is actually positively charged. So this right here has a covalent bond, and the entire thing, sodium hydroxide, is ionically bonded. So the entire thing, this is an ionic bond, but it also contains a covalent bond within it. So if you see anything like sodium hydroxide, or H2SO4, or AlPO4, or anything that is a combination from right here, this will contain covalent and ionic charges. Look at the practice problems. Speaking of practice problems, look right there! Done.